All right, with this example, we're going to take a look and see how the wind can affect one of these problems. And so we have a situation here where the baseball is being hit 3 feet off the ground, and we'll take a look and just say, okay, well, there's 3 feet, and there's the ball being hit off the ground. It says it's being hit at an angle of 25 degrees with the horizontal. So there's my horizontal. And we know that it's the speed of the ball came off the bat is 150 feet per second. So that's really the magnitude of that vector. So we know that the vectors have two components, a horizontal and a vertical component. The horizontal component would be this horizontal vector right here. And if we add it to this vertical vector right here, it would give us our resultant vector where the baseball is. So the horizontal vector is going to be 150 times the cosine of 25. And the vertical component is going to be 150 times the sine of 25. And it gives us our vertical. And so when we write our parametric equations, the coordinates of the ball at any time t will be, the x coordinate will be 150 times the cosine of 25 degrees times t, and that would be if there was no wind at all. But there is wind. And so we have an added force, not only the force of the bat. The horizontal force of the bat is 150 cosine of 25. That would be the magnitude of that horizontal vector. But we're going to add to it the speed of the wind. Excuse me. It looks like the wind is blowing in from center field. So that means that the wind is blowing this direction, which is going to slow the ball down. And so that means we are going to say -4, and that is going to, and that's, feet per second. So it's going to decrease that horizontal force by 4 feet per second. So we just say -4. If the wind had been blowing out toward center field, then it would have been a +4, 4t. And of course, I put it inside. You could have written it x equals 150 cosine of 25t, and then either plus or minus 4t, depending on whether it's blowing in or out. But I like to put it inside and just factor out, to have the 1t outside. The y coordinates are going to be given by, messed up there. The y coordinates are going to be given by -16t squared, which is our gravity force down. And then the upward force is 150 sine of 25 degrees times t. And it starts 3 feet high, so we tack on a +3. So that's how you get the equations when there's wind involved. Again, if the wind had been blowing out, it would have been x equals 150 cosine of 25 degrees +4, and then times t, all of it times t. All right, hope that helps.